Hello everyone, so we are on our fourth topic, which is capacitance. Okay, so this is actually my favorite one, my favorite topic so far. This is capacitance, and it talks about capacitors, or the measurement of how capacitors store energy. Okay, so first let's go to what are capacitors. Okay, capacitors are devices that you can find in a circuit. No? So a capacitor, it plays an important role in a circuit because it serves as a storage reservoir for energy, or energy storage, in other words. Okay, so capacitor, they are the one that supplies a quick flow of energy if your circuit needs it. Kung needed nila. Okay, so we have different kinds of capacitors. So as you see here in our example, we have different kinds of sizes, different kinds of shapes. We have the ceramic, we have the electrolytic. Okay, so lahi-lahi ang ilahang function, not function, but lahi-lahi ang ilahang capacity to store energy or store electric energy. Okay, so inside a capacitor, if you are to let's say find if you are to open yeah, if you are to open a capacitor, inside that is we have this. Okay, so pag ato na siyang i-open, we will see these two strips. Okay, so these two strips are actually metal strips. Okay, as you can see here, they have like a little paper, say a little bit of paper inside, that separates them. That's like paper. Okay, so that is actually what we call the dielectric material. So dielectric, or what we call dielectric material, or dielectrics. Okay, so balikan ako. Oops, sorry. It's around here. Okay. So, mo na siyang metal strips, and kanang iyang tanggalon karon mo na siya si dielectric. This one. Okay, so dielectric has functions inside the capacitors, and I will talk to them later on. Okay, so first we have these two metal strips. So nga naman, ang capacitor na sila two metal strips. Okay, so it's basically like this. So capacitors work by in reality, diba? Metal strips are actually neutral in nature. Kung wala pa sila gisaksak or wala pa sila butang sa isa ka source, your capacitor are neutral. Means the positive and the negative are equal. Okay, let's say equal. No? But if hatagan nato sila og source, for example, here we have a battery as a source, hatagan nato sila battery. Okay. Now, we have this what we call the electric force, no electric force between them. Okay, so if this have positive and negatives on it, this battery or this source sucks out, um it sucks out, or asa man ang positive ani tanong sa nako asang positive. Okay, here. So this battery has negative charges. As we know, in electricity, ang makahatag or ang move lang na charge in a electricity or a source of electricity are the negative charges. Therefore, if we have a source like this, like a battery, ang move raana is ang negative charge. Okay? So, if nakay source, ang iyahang negative or iyahang electrons or negative charges will accumulate in this strip. So, this becomes dominantly negative. Daghan ang iyahang negative kaysa sa iyahang positive, therefore making it negatively charged. So this part here is actually negatively charged. Okay, then what happens? Because of our electric interaction or electric force or attraction, no? Diba? Like charges repel and opposite charges attract. So since this part here becomes negative, ang mga electron ani na part will be repelled. Malayo sila. The positively charged will be attracted to the negative here, negative strip. Okay, that is what we call the electric interaction between them. So ang isa kay dominantly negative, kaya mas daghan siya negative charge, but the other one, because of that attraction, mo repel ang mga negative charge diri ang side and moanhi sila sa sa positive terminal sa ato ang source. Okay, or na dire. Okay, so this kinang repel man ang iyahang mga negative charge, it becomes positively charged. So natay negative and natay positive na mga charges. And when that happens, maski tanggalon nimo ang source, wala na kay source, tanggalon nimo siya, because of the attraction between them, the positive and the negative charge, they will stay in place inside the capacitor. Therefore, pag wala na source, they still have those charges. So once maghatag na ka og, let's say, need na nimo og energy, si capacitor makahatag siya og negative charge. Okay? Makahatag siya. Thus providing a quick flow of energy to whatever device that needs the energy. Ayan na siya. Okay? So then we have what we call the dielectric that separates the two. Okay, so unsa na siya ang iyang role sa atong dielectric? Remember that dielectric acted like a separator within two. So, kung makita nimo dito sa ato ang video, so you can see here, it separates the two strips. Yun ang i-separate na niya. That is because dili nato sila ganahan na mubalhin ang imuhang negative charge na gikan diri okay, dili nato sila pwede idikit. Ngano man, kay ang mga negative charge diri mubalhin na siya diri. So we need a separator or what we call a dielectric material that can promote electric na interaction. So bali naagi hapon ang attraction sa negative ug sa positive na plate, pero gina-stop niya ang transfer of electrons. Okay, so yung ana siya. So that is why we need the plates to separate the two. Okay, kung pilit sila duha, of course, mararag wala. It becomes neutral. Because eventually they will balance each other's charges out. Something like that. No? So that is why we have the dielectric material to promote polarization. So na negative or na positive, gi-separate niya. Okay? So the more na good conductor ang imuha, the more na good insulator ang imuhang dielectric, the better. Okay? So then we have the importance of capacitance. So capacitors, one of their importance is they are very good energy storage. They can store lots of energy. Not that lot, but depends on the device. Naiuban na dako kayong capacitance, naiuban na gamay rapod kayong capacitance. So depende sa pagkagamit sa ilaha. But anyways, most of them are for energy storage. Okay? Now, Capacitors can store electrical energy in the form of electric charge. That's what I have said earlier. Charge ni ang naka-store siya mga charge. That's why they are a storage of electrical energy. Nga nung ma-store man itong mga charge, that is because of the electric force or electric attraction between the positive plate and the negative plate. Nga nung dili man siya mawala ang iyahang attraction, and that is because of your dielectric. Okay? That promotes polarization of the two. Okay? So here, capacitors can store electrical energy in the form of electric charge. So can use to be they can be used to provide short-term backup power. Pero dili po pareho sa kanang bulag sa generator gali na kanang dugay kayo nimo siya magamit ang iyang backup power. No. Capacitors are they have a very little capacitance. So gamay ra na sila. But anyway, that is enough for the circuit that they are in. Okay, so in case na ay mga power outage or na ay mga fluctuations sa power, because as we know, not all the time our electricity is smooth. Na uban na mo blink lang kalit ang atong light, that is because of the fluctuations sa atong power supply. Okay, so next is we have the filtering. So filtering, some capacitors can be used to filter out unwanted noise or interference in a circuit. They can also be used in conjunctions with resistors to create low pass and high pass filters, which pass certain frequencies of signals while blocking others. Okay, so just like here, we have the signal input from the AC and the DC. DC, it means direct current. AC means alternating current. Alternating current, direct current. Now, during our discussions, I have explained what is AC and DC all about. DC is a direct current, so sometimes its sources are batteries. Ganon direct current siya because it is flowing on one direction only. So from the source to the load, balik sa source. Ana ra siya. But AC, or alternating current, changes its magnitude and direction periodically. So, pwede na mato siya diri sa left, tapos mabalik tapos siya padurong diraan. Mato siya sa right, and mato siya sa left, and vice versa. Okay, so every cycle maglahi-lahi ang iyahang magnitude and ang iyahang direction. So that is AC and DC. So they are represented by this. AC, it is like this wave because of its alternating directions, and DC is just one way. Okay. So naay capacitor na kanang mo-block siya og direct current and letting the AC through. So it acts like a filter for DC signals. Okay. So AC is actually gikan na siya sa mga electricity na gikan sa aneko. Okay, so kanang gikan sa ilaha kung isaksak nimo ang imuhang appliance sa inyong socket or sa inyong sockets, electric sockets, then those or that electrical energy na gikan sa inyong socket, gikan pod sa aneko, is what we call an AC, an alternating current. Okay, so that's why it changes its magnitude and direction because di ba naatay mga fluctuations and mga shortages sa ato ang electricity, but mainly because of those fluctuations and basically it's from the power grids. But the DC is one way lang, mao nang gikan siya or steady lang ang iyang flow sa iyang current. That's why it is just from batteries, car batteries, ingana siya. Okay? So, si DC, it is actually used in electronics, so computers, televisions, mobile devices, while AC is used in like power transmission. So from diri ang nga source padulong sa mga balay-balay. Those are power transmissions, no? Distributions gikan sa aneko padulong sa atong balay, padulong sa atong mga poste. So those are using AC, electric motors, and some of the household appliances. So those are ACs. Okay? So capacitors can filter. Next is timing. Timing, capacitors can be used in timing circuits where they control the rate of discharge of the circuit. So ginakontrol niya when ihatag ang energy and when bawion. Okay? So that is another importance of capacitors. So we have as timing capacitors. So usually they are paired with a resistor. So pag gina-pair sila sa resistor, usually it is for timing. Para sa timing. Okay? So this is a on-time delay timer. This is a timer na this is what we call the capacitor, kani siyang orange, and these are resistors. Resistors are the ones that limits the flow of the current, while si capacitors, siya ang mag-smooth out sa current and mag-provide sa energy. Okay? So, bale, mo provide si capacitor og energy, mo on si LED light. Then, si resistor dayon siya ang mo off. Then, on. Ano, something like that. That is timing. Next is coupling. Coupling is ginakouple nato ang duha ka separate na circuit by that capacitor. Okay, so natay circuit 1, natay circuit 2, tapos imuha siyang idugtong or imuha siyang i-connect with one another. That is what we call coupling. Gikouple nimo ang duha ka buok na circuit with the with a capacitor. Therefore, making some capacitors can allow, para itong ganina, nag-filter siya na pwede ra AC ang makapass through pero ang DC dili. So, mura siya filter pero nag-couple pod siya o duha ka buok or two or more circuits. Okay, so next is we have the tuning. So, tuning, no, capacitors can be used to tune electronic circuits to a specific frequency. So, ang mga kaaraan ng mga radyo and karaan ng mga radio and karaan ng mga television, they have this tuning capacitors. This tuning capacitors is the one that you will manually adjust, no? Or so, sila ni ang what do we call that? Mo adjust sa frequency sa circuit para ma-match nila ang signal. Diba sa una sa mga radyo, kaya di naman pareho karon na ang radyo, igo na lang nimo in next. Sa una is you need to really make sure na ang pag-adjust nimo is tama gyud siya nga signal. And kato siya na tuning, naatay AM side sa radio, naatay AM side, naatay FM side. So usually sa FM ako sa una sa ako FM akong ang nindot kaayo kay naman na dira ang mga music, no? So wala pa man kayo internet sa una. So that is why radio, if you want to listen to muragid kog old kayo. But yes, we had a speaker that acts as a radio before that it should be tuned pa. Tuned pa siya. I-adjust pa siya para makita ang frequency sa imong favorite na radio station. And before is wala pa YouTube. Wala pa YouTube, so you cannot you cannot hear the song again unless abangan nimo siya sa imong radio. Okay, so ingana siya ang ilahang speaker sa una. Okay, so within that speaker, we have what we call the tuning capacitors that will match the desired signal that you want. Okay, so that is for the tuning capacitors. Also with the TV, because ang TV sa una, though we hadn't have
this kind of TV na imuha pa siyang i-tune. But we had this TV na dako kayo ang iyahang likod. No, nga na pa ang TV sa una. But wala ko kaapas atong sa i-tune pa nimo siya. But they have this in like vintage na mga shops. Okay, so kato siya, mura gyapon siya ing ato sa radio na if you want a certain channel, you will adjust the um, frequency of your signal or imuhang channel na ganahan. Kasi yan na siya. So overall, capacitors are very important components in your circuits. No? So daghan siya mo provide sa imuhang circuits. So from energy storage to filtering, timing, coupling, tuning, actually daghan pa. But these are gamay ra akong example. Okay, so um they are very important for electronic devices. So tanan na electronic devices nato have capacitors. I don't know if we have capacitors here. I think the PC, yeah, na siya capacitors. Okay, so kani siya, gina-use nato siya to maintain the proper power and the signal flow of your circuit. No? So, tig-manage gyapon siya maintain sa flow sa imuhang kuryente inside your electronic device. Okay? So, when the size, potential difference, or charge of a simple capacitor is changed, na siya effect sa atong capacitance. Okay? So, it means if mudako ang size sa ato ang capacitor, mudako si capacitance. Why? Okay? So, the effect of size on capacitance. Pag dako ang imong capacitor, dako pod ang imuhang ma-store ng mga charges. Or, not dako, daghan ang imuhang ma-store na charge. And with more charge, more energy. And more energy, more capacitance. Therefore, I conclude, therefore, no, with the increasing surface area, kung mas dako ang plate nimo or ang metal plates nimo, then your your capacitance will also increase. So pag gamay ra siya, then medyo less ang iyahang capacitance. Okay? So next is the plate spacing. The more close they are with each other, remember nato na kanang, di ba nato electric interaction with them, the more attraction they have, the more na mo stay in place ang mga charges. Dili sila mubalik sa source or mubalik sa mga wires. Mo stay na sila sa capacitor. That is because of the attraction between them. So the more or the less spacing they have, the more dikit sila, the more capacitance. But make sure po na pag dikit sila kaayo, naa sila dielectric that separates them gihapon. Okay, para dili walay transfer of electrons, walay transfer of charges. Okay, so kung ma-transfer mo gud ang electron or ang negative charge, then both sides will lose its charge. Dili na siya positive, dili na siya negative because of the rapid losing of charges. So, dapat, less ang ilahang space with each other, pero naagihapon siya dielectric, nag-separate sa ilaha. Okay? So, yes, that is why dielectric material. So, the greater permittivity your dielectric gives, what do you mean by greater permittivity? The greater permittivity it has, just like here with glass, the greater permittivity, the more polarization. No, the more polarization can occur. So, the more polarization, the more na maka-hold ang imong positive and negative charge. So, pag naanay siya iyang polarization, mas dako ang iyang capacitance. So, that is why the greater the permittivity, the greater the capacitance. Okay? permittivity. Okay. Or because dielectric is like, yeah, it is a kind of insulator that pag usually it is an insulating material na pag ibutang di mo siya sa imong capacitor or sa imong mga metal strip, it is um it actually drops your voltage. Okay. So the more permittivity you have, the more na mo drop imong voltage. And voltage and capacitance are inversely proportional with each other. So pag mababa si voltage, mataas si capacitance. Okay. So more about that here. We have the capacitance. So capacitance in a circuit diagram, if we already know what a circuit diagram is in our past discussion, circuit diagram. So a capacitor is represented by by these symbols. So pwede siya kane, two parallel lines that is equal in size. Okay, make sure they're equal in size, but because pag dili ang isa kay shorter, ang isa kay mas longer, it means it's a source. It's a battery. Hindi siya capacitor. And this is also capacitor. Polarized capacitor. Okay? So capacitance is a measure of the ability of your capacitor to store electric charge. So capacitance can also be defined as the measure of the amount of electrical energy stored or separated for a given electric potential. So we're talking about here about the charge, amount of electrical energy stored or separated. So of course, capacitance is directly proportional to our charge. Ganun, directly proportional man siya. The more charge that you can store inside your capacitor, the more capacitance. Now, voltage, as I have said before, dali as ato ang dielectric material, the if mubaba si voltage, mudako pod si capacitance, and that is because they are inversely proportional with each other. So this C is equal to Q over V, or capacitance is equal to charge over voltage, is actually the formula for capacitance. Ano siya atong gamiton when finding a capacitance of a capacitor, of a single capacitor. Okay, so the unit for capacitance is what we call farad, or F. No? F ang iyang symbol. In honor of the 19th century English physicist Michael Faraday. Okay, 1 farad is equal to 1 coulomb over volt. Coulomb from the charge and volt from the voltage. Okay, so most of the time in capacitance problems, we will use the most convenient units for capacitance is microfarad. Kay gamay magud ang capacitance. Okay, gamay ra ang iyang ma-provide na energy. That is why the capacitance is usually in microfarads, picofarads. Ano. So you need to look at the units before you start your solving para dili mo ma-confuse. Okay? So then, okay, so we have here the circuits. I hope you still know what is series and what is parallel. No? Parallel circuits and series circuits. Now, I won't explain what they are. That's your assignment. Assignment na lang na ninyo. Okay, but I will explain what they mean in a capacitor. Okay, so sa ilang role in a capacitor. Okay. So series circuits, or let's say um, this series and parallel circuits, they're actually kinds, or let's say types of circuits that has their own arrangement of devices. Okay? So, pag naka-series ang imuhang circuit, it means flowing ra gyud siya ang iyahang, or it is connected in one direction, or isa ra gyud siya og connection ang imuhang mga devices. So for this instance, we have the capacitors flowing or arranged in one line. Okay, one line. One wiring. One connection. Okay, basta nagsunod-sunod ra na sila. Walay ambak. Okay, so when we say that your capacitors are in a series circuit or series network, okay, your capacitors are connected one after the other. Walay breakage, walay nodes, no? So walay branching out, wala. Just one after another. Okay? So, in that kind of connection or in that kind of network, if your capacitors are in series with each other, your charges are all the same. Now you might be wondering, unsa man daytong C is equal to Q over V. Ano day na siya, ma'am? This is actually if isa ra imong ipangita nga capacitance. But as you can see here in our circuit, there is 1, 2, 3, or 2 or more na mga capacitors in your circuits. So, dili kaya nato ni siya magamit. Ay, no, dili pa nato siya magamit. Ana. So, first, in this type of connection, the charge is the same all throughout. So, if you have three capacitors, C1, C2, and C3, all of their charges are the same. That is in series. Okay? So, for example, here, okay, para makita ninyo ang full. Okay. So if you are to find their total, or not total, their total capacitance is what we call equivalent capacitance. Okay? So dili gyud siya total, no, total. It is what we call equivalent capacitance, or the CEQ. CEQ is the combination of the capacitors present in your circuit if it is in series and in unparalleled too. Pero pag series siya, ingani ang iyahang tawag na to. Ingani ang iyahang formula. So that will be 1 over C1, 1 over C2, plus if you have 2 or more, i-add nimo siya dira raised to negative 1. So do not forget the negative 1. Okay? So if you look in YouTube, there are actually lots of, or there are other version of this formula, but I find this formula very easy, very easy to put in your calculator, or dali ra siya i-solve, or dili siya confusing kayo. Okay. So in series connection, the equivalent capacitance is always less than your individual capacitance, or the lowest capacitor. So let's say that let's look at here in our example. For example, here we have C1, which is 1 farad, C2, which is 2 farads, and C3, which is 3 farads. Okay? Yan na. Since they are in series, we can say that their charge is all equal. Okay? Now, if we are to find their CEQ, ang ilang CQ should be less than the lowest capacitor. In this example, your lowest capacitor is 1 farad. So it means your CQ should be less than 1 farad. Ano siya? Ano siya iyahang technique just to check if your answer is true. So tanawan nimo if ingana, if Usa pinaka lowest. Then your CQ should be less than your 1 farad or your lowest farad or lowest capacitance. So, okay, so remember here in series, same sila og charge. But on parallel, no? So sa capacitors in series, they have the same Q, but on parallel, they have the same voltage, V. So VT or 10 volts, mo na siya iyang V total or VT is equal to the V1, which is the voltage for the C1, the voltage for the C2, which is V2 and V3. Okay, so equal sila. Mo nang kinaibahan sa parallel o sa series if ingani mo hang capacitor. So sa capacitor ni siya ha. Okay. So in this type of connection, the potential difference for all individual capacitor is the same or equal sa imuhang total voltage. So the equivalent capacitance of your parallel combinations or your parallel circuit equals the sum of your individual capacitances. So technically, you just have to add them. So let's say we have 1 farad, 2 farad, and 3 farads as your capacitors, C1, C2, C3. You just have to add them. So that is 6. No? So CEQ in parallel is just adding all of them. Oy, di siya makitaan. Okay. So you just have to add them, all the capacitors, para makita nimo si CEQ. And CQ is always greater than your largest capacitor. Series, smallest, less than your smallest capacitor. Parallel, greater than your largest capacitor. Ana siya ang ilahang difference. Now, let's solve for a circuit. Okay, so in this instance is I tend to write what we need first. Okay, so we are given the VT and based sa to ang capacitance, we need to find for the C, for the V, our V is getting VT, and the Q. Okay, so since we're talking about the totals, so if we are to find the QT, the VT, kung gamitan nato si VT, then ang gamitan nato na Q is also the total, which is the QT. And ang C na atong gamiton is not CT, but actually that is the CEQ. Okay? So in this type of circuits or connections, kani siya ang imong pangitaon. Ako ilista. We need to find the VT, but VT is usually given. We need to find QT. We need to find the CEQ. Okay? So your VT here is already given, 30 volts. Okay? Now your CEQ can be solved depende sa circuit. Kung series siya, moto siya tong 1 over C1 plus 1 over C2 raised to negative 1. That is for series. But if parallel siya, you just have to add them all. So looking at this one, these are series. They are after one another. This is a series connection. So therefore, that will be CEQ, sorry, wait lang. So that will be CEQ is equal to 1 over C1. So we have 3. So tulura po natong ibutang dira. 1 over 3 C1, 1 over C2, plus 1 over C3 raised to negative 1. Okay? So that's how you will get your CEQ. Once na imo na siyang masolve. Now, using this formula, which is derived from the capacitance formula, which is C is equal to Q over V, imohan ni siyang i-derive, no? So, i-derive nimo, multiply both sides by Vt, you can get the Qt. So, Qt is Vt multiplied by the CEQ. So, makuha na nimo sila tulo. But it doesn't end there. Because if you have this connection, pangitaon pud nimo ang individual charge and individual voltages of your capacitors. So, to make it more like easier, I tend to list all the things that I need. So, not the VTs, QT, CQ. So, together with our C1, that is 3 farads, we will find our Q1, and our V1. Same with C2, Q2, and V2. And then we have C3, Q3, and V3. So this is actually optional, but I just do this para dili ko maglibog. Like, mahimo siyang checklist nako. Okay? Na kung kinsa na lang ang kulang, kinsa na lang ang dapat isolve. So, mahimo siyang checklist or a guide for me to know which is the next one. Okay? So, remember that in series, kung pila imuhang QT, mao po na siya si Q1, Q2, and Q3. So, basically, after this QT, and C1, C2, C3 is already given to sa ato ang connection, makita na nimo ang ilang individual voltages. Okay? So, it is basically like this. Okay? So, una sa CEQ. So, whenever um, I tackle this kind of network or circuit, I always start with CEQ. So CQ, it is a series, so that is why we have 1 over C1 plus 1 over C2 plus 1 over C3 raised to negative 1. So 1 over C1 is 1 over 3. C2 is 4, so that is 1/4. Then C3 is 5, that is why it is 1 over 5, then raised to negative 1. Then we get the 1.277 farad. Okay? So remember, take note of the unit. So kani siya diri okay ra because these are just farads. Wala siya micro, wala siya pico, dili lahi-lahi iyahang unit. So okay ra. Dili na nimo siya need i-convert. But you need to be wary kay naapoy mga ingana na instances na ilahi nila ang ilahang mga units. But I won't make that. I won't do that. I won't do that. It's a waste of time. So here, next of our CEQ, kaya na naman tayo CEQ, no? Yes, na tayo CEQ. We will go, asa na to? So, na tayo CEQ. Our CEQ is, checklist man ako ning. Check. Na tayo VT, 30 volts. So, we can get our QT. We can get our QT by the capacitance formula. So, QT is equal to CEQ multiplied by VT. Okay, so that is 1.277, which is our CEQ, and 30 volts, that is our total voltage. So that our QT is 38.31. Therefore, we can check the QT and check the individual charges too, kay equal naman sila. Okay, so with that, we can get the individual voltages of our capacitors. So, gamitin na po nato ang capacitance formula. But instead of the totals, katong atong gihimuan ni diri is total man ni sila. We will go with the individuals. Okay? So, 'di ba dili siya makita. but C1 or C is equal to Q over V. So if we're looking for V1, then we will use the C1 and the Q1. C1, Q1 is already given. C1 is 3 farads and Q1 is 38.31. Same with the QT. Therefore, in finding V1, we have to derive. Okay, so correct, that is cancel. Tapos divide both sides with C1. Therefore, V1 is equal to Q1 over C1. And that's what we did here. Ganitong gihimo diri the individuals. Okay, so your QT or your Q1, QT akong gibutang dira, but pwede put Q1. So Q1 is 38.31 divided by our C1, which is 3. So that is 12.77 volts. To V2 pod, so we have Q2, which is 38.31 coulombs. Then we have 4 farads, so that is 9.58 voltage. Okay, so V3, we have 38.31 coulombs over 5 farads, we have 7.66 volts. Now, the trick here is, if series siya, if we are to add the individual voltages, dapat mubalik siya og VT or the 30. Okay, so that is why mura na po siya self-checker, self-checker. If, para makabalo ka, if tama ang imuhang resolve. Okay, something like that. I hope that is clear. No, so, mo to na, pag i-add nato sila tulo, that will go back to 30.01 or we need, or ato siyang i-round up to 30 or i-round off nato into 30. 30 gahapon. Okay, so tama ato ang solution. Now, what if it is something like this? As you can see, this is not a series, kaya naaman siya branches. So, pag it branches out, it is parallel. And in parallel, so naatay, ilista sa nato kung unsay naa sa toa. Oh, so mani. Unsay naa sa toa. First is we have the VT. Then we have, wait, butang lang sa nako ang CQ na lang. CQ. We have the VT. And we have the QT. Then, duha raman nato ang capacitor, so that will be C1, V1, and Q1 only. Then we have C2, V2, and Q2. Okay, so this is my checklist kung sa to ang needed. Okay, so first we will solve for the CQ. The CQ in our parallel is just adding the two of them. So as you can see, they are both having this micro coulomb or microfarad. So the trick is, my technique is, if pareho sila og prefix, micro, micro, then you just have to copy that. Becomes microfarad. Pareho man sila microfarad. Since i-add raman nato sila, i-add ra nimo ang iyahang value. 90 plus 85, so that is 175 microfarad. And that is your CQ. Okay? Tingnan na siya. That is how you tackle same prefixes. So, pag pareho sila nga P, then just put the P pod, instead of micro, they are both P. Then it becomes picofarad. Then 175 picofarad. Okay? So, nga na siya. Para dili na ka mag times 10 raised to negative 6 sa imuhang pag-add. Okay? That is a shortcut. Okay? So, CQ na 175 microfarad. Then we have the VT, which is 15 volts. So we can get the QT by the capacitance formula. So that will be 100, oh no. Yaman, QT. That is 2.625 times 10 raised to negative 3, or yeah, that is like that, 2.625 times 10 raised to negative 3. Okay. So then, pag nanatay QT, we're done with the QT, humana. We'll proceed with C1. C1, kung unsay mong VT, that is 15 volts, that is also V1 and V2. Therefore, using the same formula that how you get your QT, maupod ang pagkuha nimo sa iyahang individual charges. So, that will be 90 microfarad multiplied by 15 volts. So, another technique of mine is if naa siya'y micro or na siya'y prefix, pero ang isa kay wala, i-retain ra nimo um i-retain ra nimo ang iyahang what do you call that? Iyang prefix. Okay? So, pwede siya micro, then farad multiplied by V is coulomb. Okay? Then you can multiply 90 with 15. So, that is around 1,350. Tama ba? 1,350. 90 times 15. Yep, 1,350. I'm correct. So, 1,350 microcoulomb. So, yung ano siya. Okay? So, 1,350 microcoulomb is also the same as this. Kani siya nga technique ra nako is an old version where gihimo gid nako siyang 90 times 10 raised to negative 6 multiplied by 15. But then I realized na pwede ra din ako ni siya himuong ingan and it's still the same. Easier. Okay? So next we have the same, no, na Q2 is equal to C2 multiplied by V2. VT akong tawag diri, but still it's V2. Okay, same raman ang VT o V1 and V2. So 85 microfarad, then 15 voltage. So 85 multiplied by 15, so that is around 1,275. Then na siya micro, so copy the micro. Farad multiplied by voltage is coulomb, so that is 1,275 microcoulomb. That is your Q2. This is your Q1. So, if you are to add them, 1,350 microcoulomb plus 1,275 microcoulomb. Okay, tama ba? Yes. So basically, you'll go back. You'll go back to your QT, where your QT is 2,625,000 microcoulomb. Okay. So yan na siya. That is one of my technique. Labi nagna siya prefix. So para dili na ako mag-time, dili na ako siya scientific notation galing. Kato na lang value niya ang ako ang i-multiply or i-divide if it is division. Okay. So then we have the what we call the combination. So bear with me with this kay I am actually comfortable if sa board na ko siya is-solve kay mas daghan ko'y masulat kaysa diri as ako ang computer. So hinahinahayon na ako siya. Okay? So first is we have this combination. Combination is very exciting because it is na siya series, na pa siya parallel. As here, we have a series, a parallel within a series connection. So, the technique here is to find kung kinsa ang imuhang una na pwede makombine. And in here, we can combine C2 and C3. Okay, so if we are to find to look for our checklist or to construct our checklist yun. So we have our CQ, our VT, our QT. Okay. Next is we have our C1, our C2, C3, C4, and C4 ba? Ah, yeah, it's just C4. Then we have our V1, V2, V3, and V4. Then we have our Q1, Q2, Q3, and Q4. But, naatay i-add ani nila. So, ito i-add nila. As you can see here, pwede natin makombine si C2, si C3. Therefore, adding information here. So, we will have C2, 3, that is the combination between C2 and C3. Since natay C2, 3, naapod tay V2, 3. And since we have V2, 3 and C2, 3, we also have Q2, 3. So, mao ni sila ang atong pangitaon. Okay? So, bear with me for a second. Bear with me with this kay medyo taas ang iyahang process. But I promise you that it will, pwede rin niyo siya mabalik-balik, no? Or so that you'll be comfortable enough to solve this kind of, tawag na kind of connection. Okay, the combination is actually very nice. Okay, so first is tanaw na to ko sa atong masi-combine. And here we can combine C2 and C3 and they are in parallel. Remember that parallel can just be added directly. So 15 microfarad plus 5 microfarad, so that is 20 microfarad. So we have C23, where C23, yun naman eh. C23 is 20 microfarad. Okay? So, once imuha na ni siyang makombine, they become a series. What do you mean by that? So, ako sa itago akong noun. Okay? So, nga ni siya at first. So, we have our battery here. Then we have our C1. Then we have our C4. And then our C23. Sorry. Bear with me. Okay, so like that. Since na-combine or makombine naman nato si C2, C3 with this becomes one single capacitor. So, this becomes like this. Wait, yan na to siya, per battery na siya. And this capacitor here will be C2, 3. The combination of C2 and C3. So this is your C1 and this is your C4. Therefore, C1, C2, 3, and C4 are series with each other, forming the CEQ. So, CEQ is actually 1 over C1 plus 1 over C2, 3 plus 1 over C4 raised to negative 1. So, yan na siya. So, you have your CQ. Now, how about the VT? Our VT is 100 volts. So, you have 100. Okay? Now, they are series. So, it means, pangitaon pa nato ang iyang QT. So, QT can be solved using the capacitance formula. So, QT is, okay, so nga na siya. So, look at here in this part. Ganun siya nga part. I-solve na ko ang QT. So, QT is equal to CEQ multiplied by VT. So, that is 5 microfarad. Asa nagikan ng 5 microfarad, ma'am? That is the CEQ na imuha siyang gi-combine ang 1 over C1, 1 over C23, and 1 over C4. Remember that 1 over C1 is 10. So 10 microfarad. C23 is 20. So that is 20 microfarad. And C4 is also 20 microfarad raised to negative 1. So that is CQ is 5 microfarad. So this is the CQ. Kung sa result nila ani, the result niya. Okay? So with this 5 microfarad multiplied by 100 volt, we can find the QT, which is 500 microcoulomb. So remember my technique na may micro si farad, si volt is wala. So you can as is, again, as you can see here, 5 has micro on it. So micro, copy na nato siya. Now farad multiplied by volt, or by farad multiplied by volts is coulomb. So that is why 5 times 100 is 500, then the micro, and then the coulomb. So that is our QT, 500 microcoulomb. Ano na siya. Okay? So, ano na siya. 500, 5 times 100, 500, micro from the microfarad. Copy lang. Farad multiplied by voltage, coulomb. So then, we have our QT, which is 500 microcoulomb. Kamoy sabot ana. Okay, so I don't have my pen with me, so that is why I cannot write properly. Okay, so remember that QT, or in series, your QT is equal to your Q1, Q2, your Q1, your individual Qs. Ano na lang, your individual Qs. But, in here, ang QT nato is 500 microcoulomb, pero ang involved na capacitor is C1. So, si C1, naa siya 500 microcoulomb. Si C4 pod is naa siya 500 microcoulomb. But not QT and Q2 and Q3. That is because si C23 man ang series kay C1 o kay C4. I hope you understand that. Siya man ang naka-series kay C1 o C4, that is why siya pod ang the same sa ilaha o Q. That's why instead of Q3 and Q2 ang 500 microcoulomb, ang ato ang hatagon sa 500 microcoulomb is si Q23. So that is 500 microcoulomb. Okay? So using our C1, C4, C1 nato is it 10? Yeah, 10 microfarad. C23 nato is 15 and 5. Then we have 20 microfarad. So then we can solve for the V1, V4, and V23. So V1, we can use this as our highlight, as our solution. Okay, so V1 is equal to QT or Q1 over C1. QT akong butang dire, but it can also be Q1. Q1, Q4, Q2, Q2, 3. Okay, so that is 500 microcoulomb over the C1, which is 10 macrofarad. So remember the technique that I had, no, na ay micro. Dili is pareho sila naa siya micro. Therefore, if pareho sila na ay micro, you can cancel the micro out. So cancel ang micro, cancel ang micro. You are left with C over F. And C over F is voltage. Okay? Para dili na ka mag times 10, 500 times 10 raised to negative 6, or 10 times 10 raised to negative 6, dili na. Na-cancel na nimo sila daan. Okay? So, in this case, it is just 500 divided by 10. So, that is 50 volts. Okay? So, that is for V1. V1 is 50 volts. Sorry if it's so messy, but kamo rin sabot ana. Okay, next is we have V4. So V4 is 500 microcoulomb, then 20 microfarad. Therefore, i-cancel na to ang mga micro nila, and then C over F is 500 divided by 20 is 25. V4 is 25 volts. Okay, so then let's go to the V23. V23 has the same value with V4, so they are the same na 25 volts. So 25 volts. Okay, so na-check na nato ang mga nag-series. Okay? So if we all add all their voltages, 50 plus 25 plus 25, mubalik ka sa 100. Okay? So 100. So tama ang ato ang series na part. Now how about sa C2 o sa C3? Now remember, C2 and 3 are parallel. So sa parallel, same sila og voltage sa ilahang total voltage. But we cannot use VT here, the 100 volts. Di nato siya magamit dire. Because napabayan ni C1 o C4. Unsay gamitan nato nga voltage diri kay C2 o kay C3? Of course, katong voltage ni V23, which is 25 volts. Kay 2, 3 ba yan siya? Combination of 2 and 3. So therefore, ang ilahang voltage is also involving V2 and V3. Okay? Therefore, kung 25 voltage ang imuhang V23, your V2 is also 25 and V3 is also 25. 15 and 5. So your C here, C2 is 15. Sorry if very messy na siya. But kaya niyo yan. That is 15 microfarad and 5 microfarad. Laban. Okay. So there, kay nakuha naman nato iyang V2 and V3 using the V23, we can solve for the Q2 and the Q3. That is Q3. Using the capacitance formula. So Q is equal to C multiplied by phi. That's what I did here. So Q2, that is C2 multiplied by V23 or V2. Okay, para naman si V23 o si V2 o si V3. Okay, so 15 microfarad multiplied by 25. Remember my technique. So natay micro, so you just have to copy the micro, and then farad multiplied by voltage is coulombs. So that is why this is microcoulomb. 15 multiplied by 25, that is 375. Or if you really want it to be a long way, mag-scientific notation pa ka, okay. So that will be 3.75 times 10 raised to negative 4 coulombs. Okay. Now, how about Q3? So C3 is 5 microfarad and 25 volts from our V3 or V23. 5, that is microfarad, so may masyang microcoulomb. Copy the micro, then F multiplied by V, C, coulomb. 5 times 25, 125. Okay, so if we are to add 375 microcoulomb and 125 microcoulomb, dapat mubalik siya sa imuhang Q2, which is 500. So 375 plus 125 is 500. Therefore, nakuha naman ni mo siya, humana ka. Ingana siya ang atoang combination. Okay? So I have here examples. Na pa yung mga examples, and in my PPT they also they also have the answers there. So pwede rin ninyo ni siya himoong practice, okay, for you to enhance more of the combination, the parallel, and the series circuit of a capacitor. So good luck. Bye.